This is for Year 12 Specialists. It comes out of Chapter 6, 6G, question number 13. And this is a very, very long-winded, difficult graph to draw by hand. But I'll show you what I've done. Okay, so we have this rational function because I have one function, which is a parabola divided by another. To find the asymptotes, what I need to do is factorise the denominator into these two factors. Therefore, I'm going to have a vertical asymptote at x equals 1 and x equals 4. Then I need to do a division because I have a quadratic divided by a quadratic, so it's effectively an improper fraction. And I've done my division there. And we can now see that I have 1 plus this. Therefore, the horizontal asymptote is y equals 1. So for part A, find the asymptotes. They are the asymptotes. To draw these, I'm going to use the idea of addition of ordinates. And to do that, I need to turn this into partial fractions so that I know what 3 bits I'm drawing together. So I have completed my partial fractions and I found out that A equaled -3/5 and B equaled 12/5. Therefore, this is my function. 1 plus 12 over 5 x minus 4 minus 3 over 5 x minus 1. A hyperbola plus a hyperbola plus the horizontal line y equals 1. So to find the stationary points, I need to take the derivative, and the derivative of 1 is 0. The derivative of this will be -12 on 5 x minus 4 to the -2. And then the negative by the negative gives plus 3 on 5 x minus 1 to the -2. To find the stationary points, I set that equal to 0. I get a common denominator, expand this out, and I end up with x equals plus or minus 2 as being the 2 times that the derivative equals 0. Remembering I can ignore the denominators because the only way I can get this equal to 0 is if the numerator is equal to 0. And then subbing these in, that gives me 2 turning points at 2 and 4 and -2 and 4/9. The question asks for the type of stationary points. So I've done a sign diagram. The sign diagram is to do with the derivative. So here is my derivative. I fully factorise the derivative. I know that at -2 it's 0 and at 2 that it's 0. So I've picked a value to the left of -2, -3. That's negative. That will be negative. That will be negative. That's positive. That's positive. That's positive. Therefore, I get a negative. So that's why I've drawn it down here. In the middle, I've picked 0. If that's 0, that's still negative. 0 minus 2 is negative. 0 plus 2 is positive. So that gives me a positive. Therefore, we're up here. If I'm -0 positive, -0 positive, at -2, it is a local minimum. And then I picked a point over here of 3, negative, positive, positive, positive. So that's going to be negative. If I'm positive, then negative again, it's going to be a local maximum. Okay, so that's part B done. I know my 2 stationary points. -2 and 4/9 is a local minimum, and 2 and 4 is a local maximum. Now to draw it. So I know that my function is this. It's the addition of a linear plus a hyperbola plus a hyperbola. So that's what I need to draw. And I know that I have 2 stationary points. Okay, so what I'm going to consider is the 3 things I have is y equals 1, y equals -3/5 on the denominator x minus 1, and 12 over 5 x minus 4. So if I draw these 2 together on the one graph, I get this, where this hyperbola is drawn here, and this hyperbola is drawn here. So when I add these together, That's going to be negative, so I'm going to look something like that. I'm going to look something like this, and I'm going to look something like this. And I know that I have turning points at 2, and I have turning points at -2. Now, before, that was 2 and 4, but it wasn't 2 and 4, I don't think, was it? And I realised that 2 squared is 4, not 8, which makes that -2 on the denominator, which makes that -4, and that's -4, and that makes more sense. So these two being added together. So my final product moves everything up 1. So my final product is going to be a graph that will be down in there, and that point there I know is 2 and -4. It's going to be in there, and that I've got a turning point which is at -2 and 4/9. 4/9 will be around about there. So -2 and 4/9. And that graph is going to look like, and then be asymptotic towards that asymptote. And that's asymptotic towards that asymptote. And to find this, I need to find the y-intercept. And the y-intercept will be 4 on 4, which is 1. So obviously I can now go through these and get a nice curve happening. And that's now going to go through at 1. And that's going to be at 1. And that's my final graph.